Welcome to Fat Math. Today we're going to have transforming logarithmic equations into exponential form and vice versa. A useful skill for solving logarithmic equations. Because here at Fat Math, it's all about finding the right path to develop the fat brain that you've got. So here we have the exponential form b raised to x equals a. The equivalent logarithmic form of this is x equals logarithm of a to the base b. So what you can see, the exponent there in the exponential form is what's on one side of the equation for the logarithmic form. And the base b in the exponential form is still the base in the logarithmic form. And what's on one side of the equation here in the exponential form is what we put here in the logarithm. So logarithm of a to the base b equals x is equivalent to this one. A equals b raised to x. Or b raised to x equals a is equivalent to x equals logarithm of a to the base b. Let us have some examples. 2 raised to 4 equals 16. That is the exponential form. What is the equivalent logarithmic form of that? That is 4 equals logarithm of 16 to the base 2. As what you can see, the exponent 4 here is what is on one side of the equation, and on the other, logarithm of 16 to the base 2. So the base is still 2. Or you can have this as logarithm of 16 to the base 2 equals 4. Another example. 3 squared equals 9. We have base 3 here, exponent 2, and on the right side is 9. So what is it going to be in the logarithmic form? We have 2, which is the exponent, equals logarithm of 9 to the base 3. Okay, please observe the pattern. And then another example, 4 raised to negative 3 equals 1 over 64. So the exponent negative 3 is equal to the logarithm of 1 over 64 to the base 4. Actually, you can also have logarithm of 1 over 64 to the base 4 equals negative 3. If you write the logarithm first, then that's also okay. 10 raised to negative 1 equals 0.1. We have negative 1 equals logarithm of 0.1. If we don't put base there, that's understood to be base 10. That is for common logarithms. And lastly, 6 raised to x equals 4. The exponent x will be on one side. And on the other, that's going to be logarithm of 4 to the base 6. Okay, so please observe the pattern on how to convert or transform the exponential form of the equation to its equivalent logarithmic form. And then answer the following exercises. Okay, we have here 8 cubed equals 512. What is the equivalent logarithmic form of that? 1/3 raised to negative 2 equals 9. 9 raised to 1/2 equals 3. 7 raised to negative 1 equals 1/7. And lastly, 2 raised to x plus 3 equals 4. Okay, as what we had a while ago, we have the exponent will be on one side of the equation, and on the other, the logarithm of the number here to the base of the exponential form, or the exponential expression here will also be the base of the logarithmic expression. Okay, so let us answer. If you're not ready yet, pause the video. Okay, what the answer for number 1 is 3 equals logarithm of 512 to the base 8. If you wrote logarithm of 512 to the base 8 first on the left side and then 3 on the right side, that is still correct. The second one, we have negative 2, which is the exponent, equals logarithm of 9 to the base 1/3. Please check your answers. Number 3, 1/2 is equal to the logarithm of 3 to the base 9. And then negative 1 equals logarithm of 1/7 to the base 7. And lastly, x plus 3 equals logarithm of 4 to the base 2. Okay, that is how you convert or transform the exponential form of the equation to its equivalent logarithmic form. Okay, by the way, if you got 5 here, please drop a comment down below and let me know if you got the correct answers. Okay, next example. This time we have you will be given here with the logarithmic form, and you will be asked of the exponential form. For example, number 1, logarithm of 125 to the base 5 equals 3. The equivalent exponential form of that is 5 cubed equals 125. Or you can have 125 equals 5 cubed. Okay, the base of the logarithm is still the base of the exponential form here. What's on the right here is already the exponent. Okay, the answer to the logarithm is the exponent. And then 125 is the answer here in the exponential form. Another, logarithm of 1/8 to the base 1/2 equals 3. Please observe the pattern. The base of the logarithm is still the base of the exponential form. The exponent will be what's on the right. Okay, so we will have 1/2 cubed equals 1/8. Number 3, logarithm of 1 over 243 to the base 3 equals -5. The exponential form of that is 3 raised to -5 equals 1 over 243. Or you can also have 1 over 243 equals 3 raised to -5. How about logarithm of 8 to the base 4 equals x? What is the equivalent exponential form? 4 raised to x equals 8. It can also be 8 equals 4 raised to x. And lastly, logarithm of x plus 2 to the base 2 equals 4. The exponential form of that equation is 2 raised to 4 equals x plus 2. Or x plus 2 equals 2 raised to 4. Okay, transforming the logarithmic form into the exponential form will help us later in solving logarithmic equations, because some logarithmic equations we can transform to exponential form so that we can solve them easily. Okay, let us have some exercises. We have here 5 items. Logarithm of 100 equals 2. What is the equivalent exponential form? Number 2, logarithm of x to the base 8 equals 5. Logarithm of 49 to the base 7 equals x minus 1. Logarithm of 2x plus 4 to the base 2 equals -3. And lastly, logarithm of y minus 3 to the base 9 equals 6. Okay, what are the equivalent exponential forms of these logarithmic equations? Okay, let us answer. The first one, we have no base there indicated for the logarithm that's understood to be base 10. That is common logarithm. We have 10 squared equals 100. Check your answers. If your answer is 100 equals 10 squared, that is also correct. Number 2, we have 8 raised to 5 equals x. Or you can have x equals 8 raised to 5. Number 3, 7 raised to x minus 1 equals 49. If you wrote 49 equals 7 raised to x minus 1, that is also correct. And then we have 2 raised to -3 equals 2x plus 4. And finally, 9 raised to 6 equals y minus 3. Congratulations to those who got 5, and for those who did not, you can rewatch this video replay so that you will learn more on how to transform logarithmic equations into the equivalent exponential form and vice versa. Okay, that's it for this video. Goodbye, everyone. Thank you for watching. Comment, like, and subscribe. Bye.